Normally I would start off with a blank wall and then show you guys exactly how to wire this. But since we've already done a three-way switch previously in my house, what I want to really show you right now is a lesson on how to use your meter properly to be able to tell if a circuit is good or not. And by that I mean that if I take out my meter and I use continuity and I have no power, I can literally tell you whether or not there's any opens, any grounds, any short circuits, any faults, and I can tell you if the light bulb is good and if the switch is on or off without even putting power to it. So in 1 second I'm going to prove that to you. I'm going to show you exactly how to do that. And I can actually tell you with no power here if this light bulb will be on or will be off if I gave it power. And if you can understand how to use that function and that part of your meter, that goes 100% towards troubleshooting. Alright, so give me 1 second. Pause it. It's neat, it's straight, 90-degree angles, all that stuff nice and neat. Alright, so give me... Alright, so pause that. Get it all. I don't think that's a good camera spot now. Maybe up here. We talked about this before, how a three-way circuit works. Is power comes in, it goes to what's called the common on this switch. Okay? That's that black screw. That black screw acts like a little toggle. So basically there's always a connection to this black screw. And what happens is these two bronze screws below, in one position, the black screw is connected to one side. In the other position, it's connected to the other side. It just works like a simple little toggle. That's how easy this switch actually works. So power comes in on one side and feeds the circuit. It travels through what we call travelers. That's what you put in the bronze screws. It goes to the other switch. Depending on which one of these travelers has the power actually connected to it from here, and if it's connected to this black screw on the other three-way switch, is whether or not it can complete the circuit and go out to the load. Excuse me.
Bless you.
Oh, excuse me.
Bless you.
If the power can go all the way from the breaker, through the switch, through one of the travelers, excuse me,
God bless.
through one of these travelers and out the other common and up to, what the hell, is there a cat in here or something? Out the other traveler and up to the light, then that will complete the circuit. So now with no power here, I can take out my meter. What the?
Bless you.
And I turn it to continuity. And the first thing that I do is I always have to test my meter and check my meter whenever you change settings or turn it on. So you touch your two leads together. Can you guys hear that beep? And can you see what it says? 0. That means that's how you reset the meter, and that's how you text and check the meter, okay? So basically right now, power comes out of my panel, correct? Power always originates out of your panel. It flows through your circuit and comes back on your neutral. And you need to have that continuity in order for a circuit to be on. So basically, I can check that right here. because this wire right here that I left as a rough in, because this panel hasn't been cut in yet. This is what's called the rough in stage. And I'm just going to separate this for right now.
Hey, Mr. Nephew, I don't mean to interrupt, but Austin 3's waiting to get back in. He lost it.
What happened? I'm not worried about that right now. As long as you're here. Alright, so my black wire is my hot. This is the wire that goes onto the breaker and feeds power out to the circuit. Purposes. We ground everything, that's for safety purposes. The ground actually has nothing to do with the circuit. Now the neutral is what's called the grounded wire. It is also ground, and it has everything to do with the circuit. Okay? If you do not have a grounded return path, i.e. neutral, you cannot have a circuit. Current will not flow. Okay? So basically, power comes out from the breaker through the black wire. It's forced into the circuit. As it's forced into the circuit, it makes it to its load. Alright? And then the load is nothing but resistance. So I'm going to show you guys a trick. You see this light bulb right here? I can tell you whether or not this light bulb works with it in my hand. And I'm not going to do the thing that everybody does and goes and shakes it and sees if it rattles. How this works is, do you see this point right here? On the bottom, you see that metal point right there? Okay, if you look inside of the screw shell here, no, they can't see that at all. Well, they can on the phone, but they can't see it on the... You see this point right in here? Alright, that point is what makes contact with this point. Alright, and if you notice, see that point is connected to the black wire. That's your hot. Now, you see this screw shell inside of here? And the screw shell on this light bulb right here? Well, see, that's the other side of the circuit. It's connected to your neutral. And what happens is, power comes in through the hot, and inside this light bulb, let me put this camera down for a second. Inside this light bulb, there's what's called a filament, or some people call it a tungsten. Okay? And literally what it is a thin piece of wire that runs from this point in the light bulb up through the glass and is winded up, okay, and comes back and is connected to this screw shell. And that winding up of that tungsten, that thin piece of metal, is actually what creates the resistance. And because this is in a vacuum, that means that there's no oxygen in there. Because this is in a vacuum, it glows. This is one of the problems Edison had when he was trying to create the light bulb. It's a funny story, actually, because he had been working on the light bulb, but he had like 100 different designs, and every single one of them would either burst into flames, or blow up, or just not work. And his wife came down to his laboratory one day and said, "You're still working on that? You're an airhead." And that's when it dawned on him. He said, "I gotta take the air out of it, because what fuels fire? Oxygen, right? If you take the oxygen out, you don't have the fire." So that's when he figured out to put it in a vacuum. And as soon as he put it in a vacuum, now it worked. Well, basically, getting back to what I was saying, there's a direct connection between this point going through a tungsten or filament, whatever you want to call it, and comes back to this screw shell. So I can tell you right now, using my meter, whether or not this light bulb is good. I put my meter on continuity. and I take one lead and I put it right here at this point. Can you guys see what I'm doing? I take the other lead and I put it on the screw shell. Can you guys hear the noise? That means there's continuity there. That means that this works. But what I want to do is I want to show you the reading on my meter. So, I show you the reading on my meter. Do you see what it says? What does it say? 24. Okay. Now, that's a little bit different when I took my two leads and just put them straight together, because now what does it say? 0. Alright, that's a very important point. When my meter beeps like that, that means that there is a connection. There's certain things I want to have connections to, and there's certain things I don't want to have connections to. So like, I do not want to have a direct connection between ground and neutral or ground and hot, because that means I have a short circuit, right? If I don't have any connection at all, then that means I have what's called an open line. That's why it comes up OL on your meter, open line, okay? But when I put it through that light bulb, I got 24 ohms. That's what it is ohms. And it's a measurement of resistance, which means that I have resistance in that circuit, which means basically that it's good. If I took that light bulb and I did the same test and it didn't beep and it said OL, then that would mean that light bulb is no good. Okay, here's the spin on it. Here's the spin on it, because some of you guys might try this and it might not work for you. This does not work on LED light bulbs. This does not work on fluorescent light bulbs. This only works on old style incandescent light bulbs where there's actually a physical connection. Now, the reason why it doesn't work on LED light bulbs is because inside of LED light bulbs, they actually have a little electronic board inside, all right? And if that board is not activated, there's no connection. So you actually need power to activate that board. So now, because they have LED light bulbs, they have a new type of special tester to test those kind of light bulbs. Same thing with fluorescent light bulbs. Fluorescent light bulbs work on gas. Okay, there's gas in the tube, and it illuminates that gas. There's luminescence, and that also does not work. You can't test a fluorescent light bulb with your meter. But this brings back the regular point of how to do a circuit. And that's why I use the incandescent bulb. Okay? So right now I'm gonna keep the light bulb out of the circuit. And I'm gonna take my meter and I'm gonna go back to my panel, which is my source. And first thing I'm gonna do is I'm gonna check continuity between my ground and my hot. Because if I have continuity between my ground and my hot, especially if I have 0 volts, 0, 1, or 2 on your meter, 0, 1, or 2 means direct connection. Now that's good in some cases because you want to check connections and make sure you have a good connection. So the best connection is always 0. But when you're checking for short circuits, you do not want a direct connection between hot and neutral or hot and ground, because that means you have what's called a short circuit or a ground fault. And it's going to blow up in your face as soon as you put power on it. That's not so much of a big deal when you're just dealing with a little light bulb in a house. But it is a big deal when you're wiring up $1 million piece of equipment in a factory, and you turn it on and it blows up. That's a big deal. So you need to know how to test this stuff beforehand, because you're the guy that said it's okay to turn on. And when you're the guy that says it's okay to turn on and it blows up because you didn't check for shorts and grounds, Yeah, you're also going to be the guy looking for that $600 bonus on unemployment right now. You're going to be sitting at home. Alright, so, first thing I'm going to do is I'm going to take one lead, I'm going to put them together to recheck my meter. Can you guys hear it? Can you hear the beep from my meter? Somebody answer me, anybody.
Can't really hear you.
Here, I'm going to take one lead, I'm going to put it on my hot wire. I'm going to take the other lead, I'm going to put it right on my ground wire. And you don't hear it. What happened? I just lost them. Would you touch something? You guys got the whole thing about the light bulb, right? And how to check resistance on the light bulb and whether the light bulb works. We got to that part?
Yes, sir.
Alright. So now we want to check the circuit. And when we check the circuit, first thing I'm going to do is I'm going to check between hot and ground. And I don't want no beeping. I want it to be open line because I don't want a connection there right now. Okay? If I have a connection there right now and it says 0, 1, or 2, that means I have a ground fault. I have a short circuit. That is bad. That means don't turn the circuit on, because if you turn the circuit on, it's just going to blow up in your face. Not a big deal with a 50-cent light bulb. Is a big deal if you're hooking up $1 million piece of equipment. Okay? Now, the next thing I want to check is between my hot and my neutral. So when I check between my hot and my neutral, a couple of different things may or may not happen. It may show me open line, which is good because that means that I don't have a short circuit. Because electricity always takes the path of least resistance. So if I have a short circuit anywhere in the circuit, it's gonna show up as 0, 1, or 2. If I have resistance in the circuit, i.e. like a light bulb, which we already know the resistance of this light bulb was what? I think it was like 22 or 24? I think 24? If I get that, then that means everything is good. That means that there's no breaks in the wires. There's no short circuits. It means that the light bulb is good. And it also means that the switch is turned to the on position. So I'm going to show you that right now. Right now, I'm going to check between my hot and my neutral, and I get open line. But I don't have any resistance in there yet. Okay? So now what I want to do is I'm going to put the resistance in here. I'm going to put in the light bulb that I already checked, so I know it's good. And I'm going to check between the hot and the neutral again. And again, I get open line. So that tells me one of three things. Either I have a broken wire between here and here, the light bulb doesn't work, or simply that the switches are in the off position and the circuit can't flow through. So the simplest thing for me to check is the position of the switches, obviously, right? Because I already checked the light bulb. I know it's good. So now I'm going to put it back on hot and neutral. And I'm going to ask my wife to flip one of those switches and see what happens. Nothing happened. Oh. Nothing happened because my meter timed out. I gotta turn my meter back on. It's a battery saving function. So when you turn your meter off and you turn it back on, always touch your leads together to reset and clear the meter. So now you guys can hear that? So let's do it again. So now I'm gonna test between my hot and my neutral. And you can hear that the meter is going off, right? And as that meter is going off, I need one more hand. Because I want to show them the meter. You see, can you guys read that meter now? Hold that. And I'll hold this. When I go between the hot and the neutral, you guys see that right now? It says 24, right? That means that I have no broken wires. I have no short circuits. The light bulb is good. And the switch is on. If I was to put power to this right now without touching any of the switches, that light bulb will light up. Now, if I flip a switch, watch what happens. Now it's off. You see that? Flip the other switch, now it's back on. Flip a switch, now it's off. Now I'm going to prove it to you. So, that being said, take this, thank you. That being said, I have a temp dummy cord here that I'm going to hook up to the wires and plug into the wall and show you that right now. Let's check it one more time to see what position the switches are in. Alright, right now they're off, so I'm going to flip the switch and now they're on, right? Okay, so I'm going to leave them in the on position. I'm going to hook up this temporary wire here. So ground first, right? Now on this because it's temporary, I'm not gonna like splice and twist the wires together. I'm just gonna put them together and put a wire nut on them because it's temporary and I'm gonna take it right back apart again. But normally I would make sure I make a good splice. I'll take my heart, connect it to my heart. And this is simply just an extension cord that I ripped the cap off of and exposed the wires. And on the other side, I just gonna plug it in. Alright, so I'm gonna plug it in right here. And the light bulb came on as soon as I plugged it in, right? So that kind of proves the point that I was talking about, that the light was in the on position. Now I did all that without power. I could tell you if the light bulb worked. I could tell you what position the switch was in. I could tell you if there was any broken wires. I could tell you if there was any shorts, ground faults, or opens. And here you go. Light on, look, light off, light on, light off. All day. Keep going back and forth. All right, pause.